Sensation refers to the ability to detect or sense the physical qualities of one's environment or a stimulus. It refers to one being able to use their own five senses, which evolve. Sensation. Sensation refers to the ability to detect or sense the physical qualities of one's environment or stimulus. So, it's someone's ability to use their five senses, which have to do with touch, hearing, smelling, tasting, and seeing as well. So, these are five senses. There are three different types of threshold. There's sensory threshold, absolute threshold, and difference threshold. Both sensory and absolute threshold only refer to one stimulus, and then keep in mind that difference threshold actually does have to involve two different stimulus. So sensory threshold is the weakest stimulus an organism can detect, like the lowest volume of something, just the lowest level of something. However, absolute threshold is a more specific sensory threshold. It is the smallest level of stimulus that can be detected 50% of the time. Why 50? Well, of course, scientists know that it would be impossible for someone to be able to detect something 100% accurate all the time. So it's the lowest volume, it's the lowest brightness of your phone for you to actually see something. It's just the lowest of something for your senses to work. Next is the difference threshold. Like I said, we're talking about two different stimulus. So it's the minimum amount of change in sensory stimulation needed to recognize a change. That just means being able to detect a the smallest change of something with another thing. So for example, we have here coffee, and this has already 2 cups of sugar that you added, right? Now we have here another coffee. Now we've added 4. We have 4. So because we've added 2. You might not be able to notice a difference, but if you add like 8 more than the original, so now it's 10, you'll be able to notice, okay, hold on, this coffee mug is a lot sweeter. So then the difference threshold being 8 would be 8. So knowing the difference threshold, you would be able to use the Weber's law. Weber's law shows that threshold is referring to a constant ratio. So if the difference threshold goes higher, the initial stimulus will go higher. So if the initial stimulus needs to get higher, then the difference threshold needs to get higher. So if you start with 2 and it needs 8 for you to notice it, that doesn't mean that having 18, let's say, would need another 8 for you to notice it. Maybe you're not going to notice it. Maybe this time you actually need 20 because of the fact that the initial stimulus is now higher than what we started from a while ago. Next, we have here signal detection theory is a concept in psychophysics. Psychophysics is the branch of of psychology that deals with the relationships between physical stimuli and mental phenomena. So it refers to things that are actually physical, what's going on, and how are you interpreting it. There are 4 different possible outcomes of your reaction to a stimulus that could be present or could be absent. And here they are. When, let's say, a stimulus is present, and we'll use an example is a chair. That's the example we're going to be referring to right now. So if a chair is present and you're able to detect it, that's a hit. Got it correct. Now, if it's present, but you were not able to detect it, you were not able to see the chair, that was a miss because you missed that present stimulus. You missed the chair. It was there, you just didn't see it. Next, we have here if the stimulus is absent. What happens if the stimulus is not there, but you detect it? You were claiming that you're seeing a chair, but it's not actually there. That's a false alarm. That is a hallucination that you're having because it's the chair isn't there, but you're saying that it is. You're seeing it. That's impossible. That's a hallucination. Next, how about if it's not there, it's absent, and you say no. Yeah, the chair is not there. Someone asks you, is there a chair in your room? There isn't, and you say no, you're correct, right? So you made that correct rejection. It's important also to understand sensory adaptation, sensory interaction, and sensory transduction. So, sensory adaptation is when your senses are no longer detecting a stimulus because your sensory receptors are continuing to have contact with it. It's kind of like the stimulus is starting to die off. So, for example, you go somewhere and the room smells really bad. After 30 minutes, you get used to it and you might not be able to smell it anymore. You might not be able to smell that new paint anymore. So, because your senses are adapting to that environment because of that constant contact with that stimulus. Next, sensory interaction. So it's when one sensory modality affects another. A great example is when you're driving, right? Driving requires your full attention. Let's say, for example, it starts to rain when you're driving, and you can't really see that well. You asking to put the radio down so you could see better, that's like sensory interaction because when you do put the radio down so you could hear better, you're focusing more on the road, you're seeing as that way, I'll put the radio down so I could see better. It's because the hearing is distracting you, the hearing is affecting what you're seeing. Next, we have here sensory transduction. It's when a stimulus, so a light or sound, is converted into an electrical signal for your brain to process what is going on. And we'll go over that when we talk about the ears and the eyes.